Okay. So looking again, this is all just rehashes. The point of writing out function add 10 by value on line 6 is that FL is its own variable. So if I create a float XYZ and then I call add 10 by value and I pass in XYZ, I would pictorially represent that as I presume I have in the past. I would say that this right here is memory that was set aside for XYZ. I assigned 3.14 to it, which is what we have on line 18. And then I call the add 10 by value. I pass in XYZ, and FL is actually created and is a copy of XYZ, or to put it a different way, the value inside of XYZ is what is passed into FL. Therefore, that would be referred to as pass by value. And so FL is literally created as its own variable. The 3.14 gets copied, and then here I'm adding 10 to it. That modification is actually occurring to this variable and doesn't change our original. We hit the end of the function, FL goes out of scope and dies. Contrast that with this. So the question was, how do you pass by reference? There's actually a long answer to this that involves what are referred to as pointers. And what you end up doing is manipulating addresses, the addresses being these numbers down here. XYZ begins at, in this example, at the address 100, and FL begins at the address 104. And there's actually a way of passing in addresses and manipulating the numbers through the addresses. We will talk about that, but a little bit later in the semester. That has historically been the only way to pass by value in the C language. And the new way, I don't want to say that this is done instead of the traditional way. Memory addresses and pointers end up being both a really difficult concept to get your head around, and it also happens to be the single most common construct in the language that you use when you're a professional programmer. So there's no way of getting around that stuff that I'm kind of finessing right now and don't want to talk about due to its complexity. A shorter answer for a new feature added to C++ is all I have to do is I have to tell the compiler that this is actually a different kind of variable and it'll treat it differently. And I tell it's a different kind of variable by putting this ampersand right at the end of it. Now, just by that one character, note that, and then what I'm going to do is I'm going to call that function down here, add 10 by reference, and I'm passing in XYZ. Note that I don't change the way I use the function. I'll complete the circle here in a moment. Note that I don't change the way I use the function. There's exactly one place in my application where I change things, and that is in the parameter to the function. So I'm saying this parameter is not a float in the same sense as it was in line 6. It's something different. The way I would read that is I would say that XP is a float reference, or colloquially I would say it is referring, XP is referring to another variable. So I would draw that differently. If I go back, I just, let me see, what's a good color? Let's put a big line here. Say these are different examples. I would start off again, in main I create FL, so I do that. Line 18, we've already looked at line 19. So line 20, I pass in, oops, excuse me, that's supposed to be XYZ. XYZ is the 3.14. That's our line 18 here. And then I get to line 20 and I pass XYZ into this function here. But again, this is, I would say XP is a float reference. And the way I'd represent that pictorially is like this. xp is not its own variable. It is merely another name for a variable that already exists. Okay? Now, anything that I do to xp, I'm actually, oops, there we go. Anything I do to xp, I'm actually doing, in this example, I'm doing to xyz, where I called the function on line 20. So this would be passed by reference, which means that you're passing an actual, the variable that you want to refer to inside the function. Okay. And now here, this would add 10 to it, and that would end up making that 13.14. So that's passed by reference.